Hello, welcome back to another episode of Math with Haas. You are watching Precalculus Season 2, Episode 6. We are continuing our discussion of trigonometry, and so we're going to begin where we left off in the last video. We talked about in the last video that the arc length is equal to s times the radius times our angle theta. Butchered that. Alright. So theta we talked about was it was measured in radians. It's a unitless measurement, and it was based on the ratio of the arc length divided by the radius. Right. So this was how we came across determining a way of measuring angles. Is doesn't matter what the radius of the circle was, we could look at this ratio here and it would always be the same. And so this gives a new way of thinking about angles. So when we think about our circle now, we talked about how if we form an angle theta, then we would have we form the following figure here, right? So here's our radius r, and then the arc length is this distance here. And the language we want to use is the arc length is this distance that's subtended by our angle theta, okay? So that means from where we start on the positive x-axis, we go some angle theta, and where we stop, this distance here is our we think the amount traveled along the circumference of the circle. So if we call the circumference of a circle, c is equal to 2 pi r. Alright, so let's go ahead and just note this is that was bad. Alright, this is arc length. There we go. That was our equation for arc length that we derived last time. So let's go ahead and work through an example. So if we are told that the angle is equal to, how about something like 3 pi over 4, and the radius is 5. And if we want to find what the arc length is, then all we have to do is say, well, s is equal to r theta, so s will equal 5 times 3 pi over 4, which is just 15 pi over 4. It's as straightforward as that. It's a relatively simple calculation, but it's a very useful one for determining these distances. How far along the circle have we traveled? Now, we do have a new question. So if we come back to our circle here, there's a new question we can ask. So if we're going to highlight this. So this area here in orange, that is called a circular sector. Okay. So this shaded orange region, again, this is a circular sector. We should probably fix the eye there. Make it more look like an eye. There we go. So circular sectors, we can raise the question, how do we find the area of this, right? So what is the area of our circular sector? That is the question we want to think about. So looking at it, we know our area here is it's a portion. It's it's a portion of our entire area of the circle, right? It's just some ratio or just some percentage of the entire circle. So if we think about this a little bit, we know that the area of a circle, so I'm using a big circle there to indicate area of circle. If we think about our area of our circle, it is equal to pi r squared. Okay. Now, if we want to find the area of a circular sector, then what we need to do is figure out what is how much of the circle falls under this shaded region that's orange here. So we want to think about what is the percentage, if you want. What is that proportion or that ratio? How much of the circle is actually here? So when we think about this sector here, we are cutting an angle of theta out, right? So the fraction of the full circle, then, we could think of it as theta over 2 pi. So this ratio here is going to be let's see. So this is going to be the amount of the circle in the shaded area. So if we think back to theta, we said it was arc length over radius here, right? It was that unitless measure. So another way we could think about it is arc length is r times theta. And if you think about the circumference, it was 2 pi r. So what we're getting at here is theta, when we divide it by 2 pi, that's going to tell you just how much of a the percentage of how far along we have traveled of the circle. So for example, if theta was equal to pi over 4, let's just draw a small diagram here. Pi over 4 is this angle right here, pi over 4. We talked about how this would be 0, pi over 2, so we cut that straight in half. We get pi over 4. Well, pi over 2 is 1/4 of the circle. So we should expect pi over 4 to be 1/8 around the circle. So if we take pi over 4 and divide that by 2 pi, notice we get pi over 4 times 1 over 2 pi, which gives you your, well, the pi's cancel out, and that gives us our 1/8. Or if you want to think in terms of percentage, this is 12.5%. Right? 1 divided by 8 is 12.5% of the circle. And we can do the same with the pi over 2, right? So claim is this was 1/4 of the circle. So here we can see that the pi's will cancel out again. That leaves us with 1/4, or it's 25% of the circle. So that's some justification for this claim, that the amount of the circle in the shaded region, right? So this gives us the percentage. So if we want to know the area of the circular sector, so area circular sector, that's a gross subscript, but we'll run with it. The area of the circular sector then is going to be theta over 2 pi. So this tells us the percentage, right? So that is how much of the area is this. And since we're concerned with the area of the entire circle but only the small part, if we multiply this percentage by the overall area, then we'll get our area of the shaded region. So we're going to multiply this by our equation for the area of a circle. Notice the pi's cancel out, and so this will equal 1/2 theta r squared. Or you can rewrite it as 1/2 r squared theta. I think this is how law textbooks will write it. So this is how we find the area of a circular sector. So this is our new fun fact we want to memorize. In fact, this shows up every once in a while in the future, calculus later on. It's a good fun fact to have in the back of your mind. And so if we want to update our example to find what is the area, well, area would equal 1/2 times 5, well, 5 squared, times our 3 pi over 4. So let's see here, 5 squared is 25, so we get 25 times 3 pi over 4, and we got our half hanging out. So 25 times 3 is 75, so we got 75 pi, and then 2 times 4 is 8, so 75 eighths pi. So that is the area of this orange shaded region when we have a radius of 5 and an angle of 3 pi over 4. Alright, so I guess the summary then is, zoom out a little bit more. Alright. So we have an arc length equation that's s equals r theta, and we have the area of a circular sector that is 1/2 r squared theta. So let's just put it on the same screen here. So arc length s equals r theta. So these are our two equations that we'll want to keep in mind for future reference. With that, we've come to an end of this video. Thank you for watching. If you've been enjoying our content, please subscribe to our channel and consider supporting us on Patreon. We have all sorts of cool perks for you there. Alright. Other than that, thank you for joining our math party, and I will see you next time.